Welcome to the Public Interest Technology PIT Colloquium. My name is Roba Abbas and I'm a visiting professor at Arizona State University School for the Future of Innovation in Society and a senior lecturer in the School of Business at the University of Wollongong, Australia. Together with the director of the Society Policy Engineering Collective, Professor Katina Michael, we are bringing you another session in Series 3 of our colloquium. Thank you to our colleagues Melissa Waite and Anna Reed from Arizona State University for their logistical, marketing, and communications support. The Public Interest Technology Colloquium is an opportunity to hear from our global community about the social, regulatory, and ethical considerations relevant to the design, development, and delivery of technology in the public interest. The colloquium is underpinned by the PIT philosophy that is intended to draw people together from across disciplines to address global challenges. Public interest technology, at its core, requires shared meaning which is translational. It is to be inclusive rather than exclusive. It is transdisciplinary while also respecting the disciplines. We would like to welcome our guests for today, Associate Professor Mauricio Mejía and Mareike Smolka. Our speakers will each be delivering a presentation contributing to the overall theme of designing for health, sustainability, and human values, followed by an opportunity for reflections and questions. For our live attendees today, please note your questions and reflections in the chat window as we go through the two presentations, and we'll do our best to address these after we hear from our speakers. I would like to welcome our first speaker for today, Associate Professor Mauricio Mejía. Mauricio Mejía is an Associate Professor of Design and Assistant Director of Research and Knowledge Enterprise for the Design School at Arizona State University. His research focuses on approaches of strategic design for intentional change, incorporating theory of change and future studies. He explores how professional designers or stakeholders can co-design in health and sustainability challenges. Dr. Mejía studies and works with emergent and strategic design practices such as visual sense making, interaction design, service design, systemic design, and design futures. He received a PhD in design from the University of Minnesota Twin Cities and a Master of Design degree from the University of Cincinnati. Dr. Mejia's presentation today is on the theme of design for change in health and sustainability, where he'll map out scales of design for change, discussing potential methodologies and approaches, and reviewing the skills needed in this new practice using examples in health and sustainability. Welcome, Associate Professor Mauricio Mejía, and thank you for joining us at the PIT Colloquium.
Thank you so much. I am very happy to be here. Thank you, Roa and Katina, for the invitation. So I'm going to talk about design for change in health and sustainability. This presentation is related to many things I have been working on in the last couple of years. Some of the things are still in the works, but I am very excited about this topic and how I can get more designers to think about change in an intentional way, and also get people that is interested in design to see how change can be done. So I'm going to start with this idea, the general idea of design. So when you see this image, you probably ask, I would like to ask, is this design? And probably this is an obvious answer. Many people say, yes, this is design. This is exciting. This is a nice design. I would like to have one of those. So a lot of design work is related to delight. So how things could be attractive, things that you can enjoy, things that are very spectacular. You see something like this too. So different design, traditional design disciplines. And this is an example from architecture. And maybe some of you don't know, but this is the museum in Bilbao, designed by the famous architect Frank Gehry, and it's delightful too. It's something that you want to see. If some of these things are in your city, you are proud of it, and you are like, I want to be in that building. I want just to go through it and have this experience. The bridge is kind of nice. And the spaces, everything is about the light in this particular design. but not everything that we design is about artifacts that you can touch or you can move through, that you can experience physically. Some of the experience that we design are more intangible. So thinking about something like this, in a hotel, for example, a service in which you can go and relax, and things here can be designed. I mean, some elements here in this image are aligned, the image, the objects, the lighting, everything's about a good experience that can be designed. And this is very related to traditional design stuff. Like, it's delightful, you want to have this experience, it's something that is desirable. But other things are even more intangible. So I don't know if everybody in the audience is familiar with ASU, but ASU has been, in the last few years, the most innovative university in the US. And we have a president that has been in the institution for almost 2 decades. And he has been a designer of the new American university. So at this level is more abstract, more intangible, but he actually talks a lot about design. Even in our charter, we have the 8 design aspirations, which are concepts or elements of the design of this organization. And I would say, yes, it's design, and it could be delightful. Of course, I mean, everything that you see from the, I mean, sometimes in the inside and from the outside, it's like, okay, ASU is a very powerful institution that is doing so many things that are excellent, attractive, and powerful. So somehow when you go from this artifact level to, I mean, tangible artifact to the intangible artifact, you can keep the concept of design, things that are attractive and delightful. And then, is this design? So maybe this is a harder question. Until far, everything we saw was things that are attractive, delightful. But when you see this image, not so, right? It's like, this is something that is actually uncomfortable to look at. But has this been designed? And probably many people might say, no, it's not been designed. I mean, there is not like a designer in a studio, or there is not like a particular person working to say, okay, we are going to make this mess. And yet, this is an outcome of how we have designed as a human species, the world we live in. Is this design? So, of course, the previous image was about sustainability and the sustainability challenge, but we also have a huge health challenges like obesity. So has this been designed? Of course, that's not like a person trying to say, okay, we are going to get to the objective of having 60% of the population with obesity in the US. Or I mean, I don't know the percentages right now. I know that more than half of the population is overweight, but I am not up to date with the numbers. But is it been designed? Not by a particular person, but it's an outcome of the lifestyles that we have. And design has a role in different levels. I mean, artifacts can support these challenges, or not support or cause these challenges. But also other things that are in the more intangible level, like organizational level, social systems level, and we are causing these problems from these different levels, not just those designing gadgets or cars or buildings, but they actually help or support that process. So when we have health and sustainability challenges, what can we do? So, right, that's the question. Many people have been talking about human-centered design as a recipe for many things. And actually, you go and do some research, for example, in health, you will find that many people in health are talking about human-centered design and how you can use this approach to deal with complex problems in health. Same goes for sustainability and many other complex problems. like literacy, financial challenges, I don't know, I mean, all sorts of things and many social challenges that we have. So human-centered design, there is in the design community, there is a reference for this is Donald Norman. He has been working in several books related to this. In one of these books, Living with Complexity, which is actually not the newer one in the concept of human-centered design, but another one, he has this line: we must design for the way people behave, not for how we would wish them to behave. And this is very interesting because this idea, I mean, this value or this proposition here in design is that design is basically adapting anything that we do to people. And that might be good for some things. I mean, if you are designing a door, I mean, Donald Norman has the door example. I mean, these typical doors where you don't know how you have to push or pull to enter a space or get out of a space. So yes, you want to know how people behave in order to design a good door. And many other things like interfaces in your cell phone, objects, spaces. Yes, I mean, this proposition makes sense. We want to design for the way people behave. So design is not disrupting people and actually helping people to interact with everything. But if we go back to this idea of the health and sustainability challenges, so there are some behaviors of people and organizations and systems that are not working very well, right? I mean, we have this waste problem, we have obesity and so many other diseases. Should we design for the way people is behaving right now? Probably not. So human-centered design is not that good, I argue. So these are some examples of human-centered design. I mean, if it's like you have to design buttons or interfaces or interactions that are very easy, comfortable, and yeah, you don't have to think a lot. You just they are very intuitive. That one, the previous one from more traditional design, like industrial design, but human-centered design could also be applied to intangible situations. So this is an example, a nice story I found in the past few days about a person called Paul Brown, and he was not able to grab a Starbucks coffee before boarding a JetBlue plane. This was back from 2013. And what JetBlue did to improve the experience of this guy was to bring a cup of Starbucks coffee to the plane for this person, and this person was just so happy. And again, this is really good experience, human-centered design. We are talking about the needs and wants of people. And of course, if some things like this happen, is again delightful. And not only delightful, but of course, the functionality and it's very comfortable, and I mean, a lot of good things, right? But again, human-centered design, I argue, is not enough to deal with health and sustainability challenges. Very limited. So I propose this idea of design for change. And I just, design for change is not something I am making up. I think it's an idea that I am using to cluster other things related to designers or non-designers trying to use design methods to deal with these issues. So there are other concepts out there like social design or design for social innovation or transition design, civic design. So many emergent practices here for this idea of design for change. But then when you think about design for change, it's like, okay, everything that we design changes something. I mean, even if you are just coming up with an ad, like a poster, or designing an interface or an object like the trash bin, all of these objects are trying to change something, like a behavior in people, or attitudes, or making a system better, or changing something in the system. Everything in design is about changing. But the problem in design practices, I say, is that usually it's not very intentional. So I think the idea of design for change, to make it more explicit, is, okay, how designers could be more intentional about change. And not just think about the light, not just think about comfort, or think about usability, but also think about changing things that maybe are not ideal, like, again, health or sustainability. So these images here are a couple of examples of intentional change. So, for example, I mean, this is a very simple example in the left, is when you get a subscription, a registration form, you can have a checkbox that is by default checked in or checked out, or and that is going to make a difference in how many people is going to have will be subscribed to favorite deals in this case. So many of these examples that we find when we talk about design for change are about using behavioral science to make design decisions. So the example in the left is a cognitive bias or behavioral bias called default rule, which is everything that is by default is more likely for people to do. So you can actually design things to change behavior of people by intentionally, you as a designer, trying to use this behavioral theory to achieve a change goal. In this case, changing the behavior of people to get more subscriptions. The same goes for the right image, is this idea that in behavioral science, one of the concepts is that we have a lot of irrational behaviors. So we are very inattentive, and then things like the speed limit display here is reminding people and making them rational about something. Just trying to think, okay, this is happening, so they can change a behavior. And this is great. I mean, we can apply behavioral economics, behavioral science, nudges in design for change. But there is a limitation here, and I'm going to explain this by explaining the scales of change. So one thing that you can do is thinking about change in design is changing the behaviors of artifacts. So, for example, if you are designing software, you can change the behavior of that software so it adapts better to how people behave. So basically, this first category is not about changing people, but about changing artifacts. And this can be applied to things that are, I mean, think about how you can be can be healthier, or how can people be healthier or more sustainable, but also could be applied to selling products or to, I don't know, political objectives and so on. A second level is changing the behaviors of individuals, which is basically the previous image. So for example, the speed limit or the speed display. So the idea there is to create an artifact, not to change how this artifact is behaving, but to change people, behavior of people. A third level will be changing the behavior of organizations. So that would be the example of ASU. So many things that President Crow has done in ASU is about changing the behavior of the organization by implementing these design aspirations, by implementing policy, by implementing different programs. So a group of individuals as an organization is changing over time. And at the bigger level, we have change in the behavior of social systems. So, and this has to do with the landfill example I had in a previous image, or obesity. So if you want to deal with obesity, you are not changing. I don't think the solution would be to change the behavior of an individual. Yeah, you can change the health situation or condition of an individual by designing something that helps this individual change a behavior. But you are not going to solve the society problem just by implementing working just on the individual level. Sometimes you can, but I think my argument is that it's very difficult to do that just because these problems are not about single behaviors. So, for example, the obesity problem is about dozens or hundreds of behaviors that somebody and many people do every day. So how you are going to design for that? I think you will have to work in the level of social system to actually have meaningful change. So what are the design practices in these levels? So the first one, when we are trying to change the behavior of artifacts, these are more traditional design practices, like industrial design or interaction design, user experience design, architecture, and interior design, so many traditional design disciplines. When I say traditional design disciplines, typically the output of design is something that you can perceive, touch, or use your senses to experience it. So again, it could be a building, it could be a gadget, it could be software, and so on. When you are talking about changing the behavior of individuals, we are talking about behavioral design practices. So you can use traditional design artifacts for this. So for example, the display in the road to reduce the speed of drivers. So you have there an artifact, like an object that you can touch. But what is important there is not the configuration of the form of the artifact or the interface of the artifact or the usability of the artifact. I think what is important there is how this concept of information while you are driving in a road is the design concept. So it's something more intangible. In the next level, we have other practices like service design, which is something I am doing a lot and teach and do research on. Strategic design also, and organizational design. Organizational design is more like a management practice, but it has some interesting design principles there and some methods that overlap with more traditional design disciplines. And then with the idea of changing behaviors in social systems, we have these new emergent practices like transition design or civic design. Okay, so I talk about design practices, but how do you practice design in these scales? And I think this is the important part here, because you can say, okay, I do civic design or I do architecture, but how designers approach the design process when they are in these levels or these different scales. And I would say that if you are more in the left, more about changing artifacts or individuals, is more expert-driven. So there is somebody that is an expert, like an architect, or somebody that is an expert in behavioral science, that is able to make decisions to say, okay, I am the expert, so I can make these decisions to do an intervention or to design an artifact. But when you move towards the right, it has to be more participatory. It's very challenging, I would say, that there is a single individual that is going to be able to design a whole social system or a whole organization. I'm not saying that this doesn't happen, because I just said with ASU, President Crow is kind of the more single designer, if you will, but there is a group there also collaborating with him, and somehow all the stakeholders in the institution have embraced some of these design concepts, and all of us are kind of designing the institution. Even in a school level, if you adopt these design principles, we are kind of moving towards, okay, what can we do to be more interdisciplinary, to be more innovative, to engage better with knowledge enterprise, and so on. So somehow there is a more participatory process there. So the organization is not something that you deliver as you deliver a building or a car. It's something that is ongoing somehow. The same goes for social systems, and that's why you need to be participatory. You are more in the left is more shorter term, in the right more longer term. It has taken almost 2 decades for ASU to change. I mean, it's been changing all the time, and it's going to continue changing. But if you compare ASU 20 years ago, 10 years ago, 5 years ago, it seems that the last ASU version is the one that is more related to the concept from the beginning of the change. In the third level here, more in the left is more about business value. This is what you see mostly in corporative design. I mean, if you work with big companies or small companies, this is basically what you do, either changing artifacts or changing individuals. Because, I mean, let's say an example, Amazon. Amazon is about how to get every single individual to buy more stuff. But you have obesity is not about just one single thing, like the Amazon's challenge. So I don't see how corporations can engage in the right ones. They can help, certainly, but we are talking more about systems now and social value. The left ones are more discrete, the right ones are more weak problems. So in these sort of levels, I have some examples here of design for change. So you are designing for individuals and you want them to be healthier, you can design interfaces like this. So trying to help people to make better decisions in the supermarket, for example, but which is the image in the left. But that's good, and that might help somebody with a particular situation. But the health challenge is not just about what you do in the grocery store. It's about so many other decisions again. Other examples like this, I mean, there are just great examples about design for change. And this is from Alder Design, a studio, and they created this for Target. And they have these really good artifacts, which is a combination of information, packaging, and also process in the pharmacy to make sure that patients or families can take the right pills in the right times. The colors, maybe you're wondering, it is just to distinguish family members. So you have 3 people taking medications in the same household, they have different colors, so they don't mix up the medications. And it's very clear, very understanding driven, and design for change, I think it is. But again, when you work in the persuasive design level or the artifact level, the change is not going to reach social systems. There is an example I found. This is a platform that has an app for physicians, an app for patients. It has also interfaces for public health managers in governments. And basically what it is this platform has been deployed in India, Bangladesh, Ethiopia, and other countries, and it's an electronic medical record system that is really simple. So they only capture a few elements of data, and by doing this very simple, they have been able to help massively many people in these countries. So I think this is an exception of how maybe you can design something that is an artifact and maybe generate change in social systems, but is typically not what you can do with artifacts. I think I'm going over time, so I'm going to try to rush a little bit here to wrap up. So what I argue in design for change, if you want actually, if you want to work in the individual change level, I think there are a lot of examples and great work, and that's good. But if you are thinking about big health and sustainability challenges, I think we need a leap in this idea of change and moving from artifacts and not just thinking about changing organizations, but actually creating visions. So this is, if you go, what you see here in this diagram is that when you create an artifact, the outcome is build words. If you are designing an organization, the outcome is bureaucratic words. And then when you go to visions and going to laws in the next step, is actually changing paradigms, which I think is one of the ways or one of the possibilities to work in this last level of changing social systems. A big challenge, of course, I haven't done it, but I study, of course, I haven't done something like that, but I study people that is trying to do that. And I have a couple of examples that I want to show you. And I would say one example is Naomi Client. So she's providing visions to people. So she's not trying to change she's not talking about, hey, how we can design a trash bin that help people recycle more. Or she's not trying to design a city bill to make people save energy, which are things that designers have done in the past, which are interesting. But I think if we actually want to address these huge challenges, I think the visions level is where we have to be working on at this level, at that scale. Another one from health is Victor Montori. Victor Montori is a Peruvian, American Peruvian, I guess, who has written this book called Why We Revolt. And basically what he says in the book is that healthcare has become industrialized and not caring for individuals. So the book is a criticism and many other things, but what is good, or one of the things he's doing right now, partnering with a designer actually, Maggie Breslin, is he's doing these demonstration clinics in a nonprofit called the Patient Revolution. And what they do is to show how healthcare could be less industrial driven and more care driven. So you see here, this description is like a demonstration clinic fosters a will to change, a vision of change, a community of change. So I think Victor is working at the vision level, which I think is a great example. And AOC is my last example. So she has this, actually, no, it's not, I think it's not even a policy like that has been concrete right now, but she has this vision of the Green New Deal. And I know others have come up with similar things, but she is selling this narrative, this vision of sustainability that I would say she's acting as a designer of so complex socio-technical systems. And one last thing is that I think if you want to be a good designer for change, you have to partner with designers, have to partner with managers, politicians. If you're a politician, partner with designers and managers, and so on. And with that, I finish. Thank you very much.
Thank you so very much, Dr. Mejía, for your presentation. Before we move on to reflections and questions, we'd like to welcome our second speaker for this session, Mareike Smolka. Mareike Smolka is currently a Fulbright Scholar at the School for the Future of Innovation in Society at Arizona State University and a PhD student in Science and Technology Studies at Maastricht University in the Netherlands. In her PhD research, she worked with socio-technical integration research in neuroscience laboratories and curated workshops to study value conflicts and capacities for ethical reflection in research on mindfulness meditation. In August 2020, she will become part of the NeuroSys project as a postdoctoral researcher in the Society module led by Professor Stefan Büchen at the Human Technology Center of RWTH Aachen in Germany. Today, Mareike will be presenting on interdisciplinary engagement with human values in science and engineering, where she'll be providing an introduction to the NeuroSys project, sharing initial methodological proposals for engaging scientists, engineers, companies, and public stakeholders to study and co-shape the emerging innovation ecosystem around the production of neuromorphic AI hardware. Welcome, Mareike, to the colloquium, and over to you.
Good. I think since you already introduced me so much in detail, we can start right with the presentation. I just would like to highlight, these are all preliminary ideas. We're still in the planning phase of the project, so I'm very curious to hear your thoughts, also maybe ideas for revisions and changes, especially when it comes to the social science methodology that I will bring into the NeuroSys project. Okay, so to get started, this is an overview of the presentation that I'll give over the next 30 minutes. So before I introduce you to NeuroSys, I will first define the problem that the project seeks to address. I will then present the vision of NeuroSys and its organization as a cluster. Afterwards, I will zoom into the society module of NeuroSys, in which I will be employed to study and co-design the innovation ecosystem that emerges around NeuroSys development of neuromorphic computing hardware for artificial intelligence. I will focus on the potential of socio-technical integration research, also abbreviated as the STEER method, to contribute to the responsible steering of the innovation ecosystem by drawing on my experience with using the method in my PhD research. I will also present the work plan for NeuroSys Society module, which includes further methodological suggestions and will hopefully stimulate some discussions in support of its refinement. Okay, so let's get started. A Google image search of artificial intelligence, or AI, returns dozens of pictures of glowing brains and blue-colored binary code floated in space. These pictures correspond to common associations with the term artificial intelligence, such as disembodied algorithms, digital data, and cloud architectures. Metaphors like the cloud imply something floating within a natural green industry. The tech sector heavily publicizes its environmental policies, sustainability initiatives, and plans to address climate-related problems using AI as a problem-solving tool. The promise of AI applications has also been discussed and criticized widely in social science literature. The literature has examined the social, ethical, and political impacts of AI applications, such as the narratives of progress and control which affect our agency. A significant strand of research has revealed potential biases of AI systems, which exacerbate social inequalities and discrimination. What the imagery and discourses around AI neglect or even conceal in the case of the tech industry's publicity is the material backbone of the technology. The semiconductor chip, as well as the wider material infrastructures in which it is produced and deployed for AI applications. And having a look at AI's materiality, we recognize two problems that urgently demand our attention. The first problem relates to the environmental impacts of chip production. A chip fabrication plant uses millions of gallons of water a day, creates dangerous waste, and accounts for most of the carbon output from electronic devices, as the Harvard researcher Udit Gupta and co-authors wrote in a 2020 paper. The example of the Taiwan Semiconductor Manufacturing Company, the world's largest chip maker, helps to contextualize the resource consumption in chip production. The company consumes roughly 6% of Taiwan's electricity, predicted to rise so quickly that it becomes the country's largest energy consumer. Moreover, the company's water usage became a controversial topic during Taiwan's drought in 2021, when the government diverted scarce resources, or scarce water in this case, to factories instead of farms. At the same time, there is a rise in global demand for semiconductor chips, which exceeds the supply, especially in light of the increase in remote work caused by the COVID-19 pandemic. The present global chip shortage stimulates countries to boost the semiconductor industry, such as the Chips for America Act, proposing 52 billion funding. And also another example is the EU Chip Act, which aims to increase the European share in the global chip market to 20% by 2030. Such ambitions clash with international climate goals, for as the semiconductor industry grows, so too will its carbon footprint. It's not only the production of chips, but also the training of AI models that consumes a lot of energy. The graphics processing unit, or GPU, is a particular type of chip architecture, which is capable of executing AI algorithms. GPUs were originally used for the graphical rendering and computer games, but with the advent of AI, GPUs acquired a number of uses and entered new markets. GPUs are thus somehow flexible. Several types of software can be run on this hardware, although they are much more specialized than general-purpose central processing units, or CPUs. GPUs, however, are relatively energy inefficient. A large portion of the energy consumed inside the chip goes into data movement from memory to computing blocks and back. With AI applications becoming more and more data-centric, this movement increases and exacerbates in energy inefficiency. Both flexibility and efficiency could long be jointly improved through miniaturization of transistors, the basic components of GPUs. Not only do smaller transistors require less energy to operate, but they are also faster in terms of processing speed. What Proctover and Vannuccini call the trilateral technological frontier of semiconductor chips, pitching flexibility, energy efficiency, and processing speed against each other, could be improved until approximately 2010, when Moore's law started to slow down. Moore's law is not a universal absolute, but describes an empirical pattern according to which the number of transistors on a chip would double every year at minimum cost. However, in recent years, the number of transistors on integrated circuits is growing more slowly, suggesting a saturation of the curve and the end of Moore's law. Miniaturization as a strategy to improve all ends of the trilateral frontier has come to an end. At the same time, AI is particularly energy intensive because training large-scale models, for instance, for language processing, can require several days up to weeks of computing time to ensure that a model's outputs are accurate. While recent advancements in GPUs have accelerated the neural network training, increased processing speed comes at the cost of higher energy consumption. Therefore, researchers have recently started to explore the use of alternative hardware that is more specifically tailored to AI. As the semiconductor industry abandons Moore's law, now things could get a lot more interesting, writes Nature editor Mitchell Waldrop. Neurosys is one of these new interesting developments. In order to reduce energy consumption, not only in the training of AI models, but possibly also in the production of its material backbone, Neurosys seeks to develop neuromorphic computing hardware for AI applications in a sustainable manner. Neuromorphic chips are a radically different development direction for computing devices than GPUs. This novel hardware architecture mimics the impulse-based synaptic activity between neurons in the human brain by wiring transistors together in a way that emulates a neural network. The neuromorphic system takes advantage of the brain's massive parallel connectivity between the neurons, which here equal the processor, and the synapses, which are the memory. In contrast to GPUs, where data needs to move from memory to computing blocks, neuromorphic computing hardware conducts all data processing in situ, where the data is located. For this purpose, new materials are integrated in chips, mainly so-called memristos, which stand out for in-memory computing. Neuromorphic computing thus removes the energy burden associated with GPUs almost completely and accelerates processing speed. It should be noted that the practical purpose of neuromorphic systems is not to replace the conventional architecture completely, but to supplement it so as to make up its leeway, especially for intelligent tasks such as image recognition and natural language processing. While the R WTH or RWTH Aachen University in the Rhine province, in collaboration with the research center Jülich, are suitable locations for the Neurosys project due to their expertise in memristal research. Worldwide, there are no pilot lines, let alone industrial capacities for mass production for neuromorphic chips. Moreover, to optimize algorithms for neuromorphic chips, matching software with hardware for increased energy efficiency, all parties in the Neurosys cluster, researchers, engineers, software developers, and industrial actors, need to work together. This requires an interdisciplinary paradigm change, especially in academics as well as professional environments, which tend to be organized according to areas of expertise. In this context, Neurosys seeks to facilitate the transfer of scientific results into sustainable business models by including a continuously growing number of regional and super-regional companies interested in AI applications for autonomous driving, personalized healthcare, smart cities, the Internet of Things, and the future of work, characterized by the use of digital technologies. The long-term vision is the establishment of a sustainable factory where neuromorphic and conventional computing hardware are integrated without leaving a massive carbon footprint. The development of neuromorphic computing hardware in Neurosys operates into two directions at once. While results from basic research give a technology push, specific areas of application have an application pull, posing clear demands to the design of neuromorphic chips. The transfer of research and development into marketable innovations relies on inter- and transdisciplinary collaboration among project partners. Moreover, Neurosys approaches societal and ethical questions, such as conflicting values in the production process and responsible applications of AI, as an integral part of these collaborations. For this purpose, research, development, and application are encircled by a sub-project concerned with innovation processes, which aims at facilitating long-term economic success, incorporating societal considerations, and orienting innovation towards European values. In the context of the sub-project, I will work within the society module led by Professor Dr. Stefan Böschen, Director of the Human Technology Center at the RWTH Aachen University. We're currently searching for another PhD or postdoctoral researcher who will join our team until we can start working on the project with joint forces in August 2022. In the module, we will study the social, cultural, institutional, and political conditions for the evolution of the so-called innovation ecosystem that emerges in and around Neurosys. And we further seek to contribute to its responsible governance. Please note that the research plan, which I'm going to present now, was largely developed by Stefan Böschen. I added several ideas by drawing on my experiences in deploying and further developing the STEER method. Before I present our research questions and methodological approaches, let me define the category that is central to our work, the innovation ecosystem. The innovation ecosystem is both an actors category and an analytical concept widely used in the social sciences. Due to its intuitive appeal, the term has been adopted by our project partners to describe the way in which a novel technology, here neuromorphic computing hardware for AI, develops and flourishes. The term has also appeared in the startup scene, where actors use it to denote wider socioeconomic context in which they find themselves. As an analytical concept, we define an innovation ecosystem according to Adner's ecosystem as structure approach in terms of the relational alignment of multiple actors who need to interact for a focal value proposition to materialize. While much literature on innovation ecosystem analyzes ecosystems in terms of the direct links between the innovator and other actors, Adner's approach allows us to trace complex interdependencies between actors who may or may not be directly related to the innovator. To combine both the actor's perspective and the analytical view, we will conduct a stakeholder analysis from the perspective of the actors. We ask, who constitutes the Neurosys innovation ecosystem? What are the distinct roles of the actors? How do these actors envision their activities and relations at different stages of the innovation ecosystem? We then intend to zoom into the industrial streams of the innovation ecosystem to map actors' opportunities for and barriers to cooperation and collaboration with other actors. Our competence mapping will reveal both explicit competences, the skills and knowledge bases within companies, and more implicit ones. Implicit competences refer to the ways in which actors take social dimensions of their work into account in everyday decision-making without being necessarily deliberate in doing so. We consider such hidden competences as often unacknowledged resources for interdisciplinary and socially responsive collaboration. Finally, we seek to identify the conditions for innovation ecosystem governance. We ask, how do actors positioned in different streams of the innovation ecosystem perceive their room for maneuvering within social, institutional, and wider political structures? Which tensions in relation to values, objectives, and interests do they identify? Which strategies do they deploy or envision to handle these tensions? We understand governance as an umbrella term for the mechanisms and approaches that steer the innovation ecosystem into responsible directions. The understanding of governance draws on Stahl's definition for a responsible innovation ecosystem, which combines the innovation ecosystem literature with discussions on responsible innovation in academic and policymaking circles. Stahl distinguishes between responsibility at the product and process level. At the product level, a responsible innovation produces desirable outcomes that are generally accepted and in the public interest. To define responsibility at the process level, Stahl deploys the definition of responsible innovation articulated in the AREA framework, which draws on the responsible innovation dimensions developed by Stilgo, Owen, and McNaughton in 2013. The acronym AREA stands for Anticipation, Reflection, Engagement, and Action, which Stahl presents as characteristics of a responsible innovation ecosystem. A responsible innovation ecosystem supports actors' ability to anticipate possible outcomes of their activities and create structures which enable reflection partly through engagement with other actors. It further widens actors' rooms for maneuvering to modify the ecosystem in ways that respond to insights gained from anticipation, reflection, and engagement. We aim at creating a responsible innovation ecosystem around the development of neuromorphic computing hardware in all our research activities. This means that a side product of pursuing our analytical objectives is supposed to be the cultivation of actors' capacities for anticipation, reflection, engagement, and action. Our analytical objectives reflect our research questions organized per project year. Although the entire NeuroSys project will run for 10 years, the first funding phase, within which I will complete my postdoctoral research, lasts from 2022 to 2024. The first year will focus on a stakeholder analysis, which does not only involve interviews with intermediaries who can help us identify relevant actors, but also scenario workshops with these actors to capture their visions of potential development path. In the second year, we will map companies' explicit competences and workshops with selected industrial actors. Implicit competences will be made visible in collaboration workshops organized in companies where we will teach employees an open-ended, person-centered decision-making tool that both captures and cultivates their often unacknowledged abilities for taking social dimensions into account in their work practices. And the third year, the conditions for governing the innovation ecosystem will be analyzed on the basis of interviews and scenario workshops with actors so as to develop a landscape with governance options at different levels or in different streams of the unfolding innovation ecosystem. Informed by my PhD project, I see an opportunity for using the STEER method in the collaboration workshops and companies in the second year of our research. Moreover, embedding STEER as a structural element for the entire duration and at multiple levels of the innovation ecosystem could help us pursue our envisioned practical outcomes, stimulating actors' capacities for responsible ecosystem governance. By turning STEER into a structural element of the innovation ecosystem, it becomes a governance mechanism. Instead of governing the innovation ecosystem with rules and regulations, which may feel like putting a stranglehold on actors, or governing with principles of best practice, which risk being reduced to box-ticking exercises, STEER is a tool for reflexive governance. It is not a constrictor, but an Ouroboros, a snake biting its own tail. The Ouroboros is often interpreted as a symbol of endless return and stands here for the open-ended, ever-returning questioning of what is responsible to do in a given situation and context, the core element of STEER. So let me briefly introduce you to the STEER method and its methodological cornerstones. STEER probes and possibly enhances the capacities of technoscientific practitioners to responsibly align science and technology development with their broader societal contexts. Classic STEER study, as developed by Dr. Eric Fisher, is a laboratory engagement project in which a social science or humanities scholar becomes embedded in a research group for a period of 12 weeks. She takes on the role of an embedded humanist who does not bring societal concerns and ethical demands from the outside to the group, but instead facilitates their internal emergence through regular cross-disciplinary dialogic interactions with selected members from the laboratory team. These dialogues take place in the midstream of research and development, when technoscientific activities are neither fully determined by upstream funding agendas, nor are they limited to an instrumental downstream approach to implementation. The midstream has long been neglected by traditional approaches to science and technology governance, although it is an important phase when scientists' and engineers' decision-making shapes research and development trajectories. STEER treats routine decisions as the unit of analysis for documenting, probing, and assessing how experts as human agents can, do, could, and should take into account and respond to social, political, ethical, and other contextual dimensions of their work. To study technoscientific practitioners' decision-making processes, decisions are mapped in regular cross-disciplinary dialogues guided by the STEER protocol, whose semi-structured questions are meant to unpack contextual dimensions of technoscientific practices. Whether reflection on these dimensions occurs and leads to practical modifications of the technoscientific workflow are empirical questions. In my PhD research, I used STEER in 3 methodological formats. My first experience with STEER was a laboratory engagement study, in which I used the method in its original format. After observing that STEER indeed enhanced reflexive capacities in laboratory researchers, I decided to use it also to facilitate group discussions on ethical challenges which all members of the research team identify as relevant to their work. Following Fisher's methodological suggestions for STEER and focus groups, the decision protocol was used to map different viewpoints, concerns, and suggestions for taking action in a collaborative process. Finally, Eric Fisher and I are developing a new method, so-called reflexive practitioner dialogues, which involve dialogic interactions among technoscientific practitioners structured by the STEER protocol, but independent from an embedded humanist. Assuming that technoscientific practitioners have native capacities for reflecting on and accounting for the contextual dimensions of their work, the method suggests that the responsible steering of technoscience can be performed by technoscientific practitioners alone, if they are provided with a tool that facilitates their own socio-humanistic critique. We tested reflexive practitioner dialogues with 25 scientists in a pilot study and observed that they raised awareness of broader social value considerations and stimulated inflections of human and material work practices. I consider STEER group discussions and reflexive practitioner dialogues as a potentially suitable method to study the innovation ecosystem emerging in and around neurosys, as well as to facilitate its reflexive governance. We could deploy STEER group discussions in companies to both study and enhance actors' implicit collaborative competences, including their reflexive capacities to account for the social dimensions of their work and professional decision-making. We could further teach actors in all streams of the innovation ecosystem to use reflexive practitioner dialogues as an open-ended, person-centered decision-making compass to build their capacities for responsible ecosystem governance. To move STEER from the laboratory to the innovation ecosystem, I propose that the 3 core elements of the method need to be adjusted. First, laboratory engagement relies on the presence of an embedded humanist, a social scientist who immerses herself in a bounded technoscientific space to gain in-depth understanding of a specific epistemic culture through participant observation. An innovation ecosystem, by contrast, is an ever-expanding environment in which multiple research groups, professional communities, and society stakeholders live together. I suggest that innovation ecosystems require social scientists to move beyond the laboratory and take on the role of engagement agents. The concept engagement agent was coined by Takulva and Lip in the context of constructive technology assessment and was later taken up by Conley and Fisher in the context of STEER to describe an individual who can traverse multiple streams and work at more than one level of innovation processes. Such actors can serve as linking pins, facilitating the communication of critical insights across the innovation ecosystem. Social scientists moving through the innovation ecosystem to teach the use of the STEER decision protocol as a self-reflection tool could take on the role of engagement agents. They could communicate about carriers and barriers of responsible ecosystem governance, which they observed somewhere, to actors positioned elsewhere. Second, STEER is meant to engage the midstream of research and development, which is in between the design and the application phase of a technoscientific project. In innovation ecosystems, however, there is not one midstream, but there are multiple streams with different temporalities that exist in parallel and may intersect. Engagement agents in neurosys need to study and engage with all these streams throughout the project and facilitate discursive, practical, and material communication between them. Third, STEER originally relies on cross-disciplinary interactions. The reason is that technoscientific expertise is often bounded by its specialized focus. Technoscientific framings of problems and solutions give rise to blind spots. Frictions emerging in cross-disciplinary interactions can reveal assumptions, norms, and values embedded in research paradigms and enable experts to question and rethink them in a collaborative process. Yet, we assume that technoscientific practitioners have native capacities to reflect on the assumptions, values, and the wider societal context of their disciplinary work. Therefore, self-reflective tools like reflexive practitioner dialogues can be taught to groups whose members can engage in these dialogues together with their colleagues. In the context of neurosys, we could collect empirical data on upscaling and institutionalizing the deployment of STEER and by extension, the responsible governance of the neurosys ecosystem. Although my experience with STEER allows me to adapt the method to neurosys, I think that the project asks for more than one methodological approach. As the innovation ecosystem around neuromorphic computing hardware for AI does not exist yet, but will emerge and solidify through the work of neurosys, scenario workshops, for example, could help us create a roadmap for possible development path and governance options. Our preliminary research plan needs to be complemented with concrete methods that allow us to both achieve the practical project goals and conduct research that contributes to academic discussions in the fields of responsible innovation, technology assessment, and science and technology studies. So if you have suggestions for how we could give more substance to our preliminary ideas or would like to collaborate, please get in touch. I hope we have time for discussion now, but please do not hesitate to contact me in case you would like to share ideas later on. So thank you.
Thank you so much, Mareike, for your presentation today. And thank you also to Mauricio. Both presentations are so valuable in terms of how we approach design and engagement with a range of stakeholders to achieve specific goals toward health, sustainability, and considerations of value. I would now like to hand over to my co-host, Professor Katina Michael, for her initial reflections, followed by questions.
What a wonderful set of presentations we've just heard. Very complementary in many ways. We are looking at an artifact to begin with. Mauricio identified that as the sort of the lowest common denominator when he showed us that we all need to buy Ferraris or enjoy the beautiful architecture in our cities and towns. But then we moved to this disruption really of chip manufacturing towards neuromorphic computing. If we go on the GPU path, as many people have noted, these GPUs probably set on fire given the amounts we will need in the distant future. But we are moving towards this new innovation ecosystem. And ecosystems, although, Mauricio, you didn't directly address ecosystems, it is a massive part of what we are talking about today. And it was very explicit, Mareike, when you mentioned innovation ecosystems. And of course, we can go back to the evolutionary economists of the 70s and 80s, Nelson and Winters, and thereafter so many others who talked about systems of innovation. Particularly, Mauricio, some of the work that I looked at very early on in my PhD studies, but what are these systems of innovation that we're trying to look at, these visions that you're describing so beautifully and eloquently? And Frank Gales, for example, talks about socio-technical transitions and sustainability, this notion of transforming and design change, but looking at the guts of, like President Crow, if we want to get to this, how do we actually make that happen? And of course, I have so many questions myself as we move to this, but I also think, Mauricio, you're talking about social transformations beyond just what we're hearing from the World Economic Forum and others of digital transformation. Okay, we get the digital transformation, perhaps that's more the human-centered approach, but you're alluding to something deeper here. You're alluding to social visions, perhaps, and social transformations, which makes me very, very happy. You also talk about the notion of participatory, which goes back to community. And that's also important in my world and in our world of public interest technology. And you talk about those higher ideals going from sort of your user experience design and your expert kind of know-how, which we all need. We still need the user experience designers, but you're alluding to something deep here, which is if we want to get people healthier, we want to get our world less polluted with a carbon zero footprint, or towards, in some cities, if we can, what do we do? And you're talking about going beyond organizations to social systems, which is delightful when we think about the scale. Mareike, your visions as well with your team and the work that you're about to embark on completely changes everything to do with how we are considering chip production, or whether we're even going to hope for chip production in the future, and how do we rejig what's actually happening in that innovation ecosystem. You know, so many suppliers around Tempe, Arizona and Chandler, Arizona, who are somehow at times trembling really to be thinking about this new wave of innovation that's coming in that may reduce our energy requirements and so forth. So very interconnected talks, you know, and also going away from, again, the artifact, Mareike, even though that is the the core concern, but going towards, well, what is this new vision of neuromorphic computing? How will it assist us? Who are the actors? You know, who are the stakeholders? How do we get this vision to the community as our demands grow for electronics, for example, or machine-to-machine learning, or machine-to-machine interactions? And that's a question I want to pose to both of you. How do we get the visions incorporated into the community's mental model that this is occurring, especially, Mareike, when we're talking about neuromorphic computing and people going, what's this about? And in your case, Mauricio, when you're looking at these huge, important, social problems, complex problems, you call them as well, we're getting away from discrete to the wicked problems and the complexity. Could you comment on those reflections, perhaps? And Mauricio, I'll start with you.
Thank you, Katina. Your reflection is really, really good, and it's helping me to think better about my ideas and understand Mareike's presentation too. And one important thing that maybe I wanted to say, I mean, because many people in design right now is talking about, okay, let's design for health or design for sustainability. So I'm not trying to get everybody to be like Alexandria Ocasio-Cortez or Naomi Client. I mean, we would, I mean, how we can educate hundreds of students at that level, of course, is going to be a big challenge. So the point I try to make is, first, that designers that are working in health are not having an impact, that they are not going to have the impact that they want to have by just doing stuff like artifacts. That's one thing. And the second thing would be that many people that we don't consider designers are actually the designers. So again, if you are talking about Naomi Client, I mean, I don't know her, but I don't think he considers herself a designer. But I think she's creating these strong visions of the future. And sometimes these visions are participatory. I want to think, like, I mean, I wish these are participatory. I'm thinking maybe about the Zapatista movement in Mexico as an example, which I am not an expert in indigenous movements, but certainly is not like a single individual, but a community that has put forward a vision that many people cite and get inspiration from. And certainly indigenous communities have collective or relational visions of the past, present, and future. It's not just about the future. So we are very future-driven in the West, but in other communities, it's not just about the future. It's about sometimes maintaining values or getting inspiration from past values to act today. I don't know if I answered any question, but I just wanted to take the opportunity to clarify that visions can be powerful, and I don't think just a couple of individuals on a small team is going to be able to develop them. It takes a village, I think, to trigger this change.
And that's an important thing, I think, to leave with in terms of my question. I often think, you know, the presence that our President Crow has had on ASU and the community at large in Arizona and beyond. But what happens when President Crow retires one day? You know, will this momentum of change and transformation that you're advocating and the design guts in, you know, is that going to go away, or will we still maintain that because he has already fostered that participation from staff, academics, students, you know, and the wider community of organizations, you know, in our ecosystem?
Yes, maybe we are very idol driven in our society. I mean, thinking about also politicians, I mean, organizational leaders, it's like we depend on these symbols for those. I mean, some people materialize those visions. Maybe that's an alternative, I don't know.
And Mareike, go ahead.
Yeah, so to respond to your question from the perspective of our project, I think it's important to emphasize that visions are dynamic, and I think it's our task to study their evolution. And I would say in our case, so when I was seeing your presentation, Mauricio, and you presented Naomi Client, and I was thinking, Max Lemmer, so the person who started the Neurosys project, who rallied so many people around the project. I mean, you saw on one slide already how many people are already involved and are engaged in creating this innovation ecosystem. He could possibly one of these people, maybe on a smaller level, but at least in our region there. He also has these innovative ideas that people agree upon. And I think what is interesting about his vision is that it allows people to fill the vision with their own value proposition. So they see what is relevant for themselves in the project. So a vision is something that is also in a way an umbrella for many different ideas and for many different benefits that people see emerging in the projects for themselves. And I think our task as the social scientists involved is to study, first of all, how are people aligning themselves with that vision? What kind of value do they see in the project for themselves? And how do they also see themselves contributing to that and to further build the innovation ecosystem together. And in that sense, I'm very curious to see, not only to see how we can, what we can find out about this visioneering process, to really put this also out as a practice and emphasize that this is a doing in a way, something very active, but also how this process of observing what's happening in terms of visioning or visioneering helps us to facilitate a responsible steering of the innovation ecosystem. So which visions are helpful and which visions are less helpful, or yeah, I don't have concrete ideas how this engagement process will unfold, but I think that's definitely our role to participate there, and just be it by stimulating reflexivity about the importance of visions and about the way in which we can all actively contribute to their creation. So yeah, I think there are many ways in which visions are very important for what we are about to do.
We have a question from Martin Mareike, which sort of dovetails on that. He asked the question, how do you think the elements of the RRI framework will manifest on the scenario workshops? And what do you expect to get from those speculative movements?
Yeah, so I think the scenario workshops are very well aligned with the anticipation part of responsible innovation. And I think the important thing is here again to build capacities for anticipating how the technology that is developed there will have impacts, both of hard nature and of soft nature, how we often say that. So hard nature is rather in terms of, will the technology, is there any potential for direct harm involved? For instance, when we use specific materials, I mean, in the semiconductor chip case, of course, the question of conflict minerals is very dominant. To what extent can we also stimulate reflections on this? So this would rather be on the hard side. but it can also help stimulate reflection on the so-called soft impacts. So how will the neuromorphic computing chip and the applications of AI in which it will be used actually change the way our society is formed, how people interact with one another, our conceptions of personhood, of culture. So rather these more subtle impacts that usually are not really at the forefront of engineering thinking. At least, that's what a lot of literature and science and technology studies shows. I mean, I'll see what engineers are telling me once I start collaborating with them. Maybe they will surprise me, because one of the nice things that's about the project that I'm working with is that the electro engineer Max Lemmer, he is really into the idea of putting society and ethics at the core of the entire project. And I think that is also very important and will facilitate the kinds of activities that we intend to do, including the scenario workshops that Martin was referring to.
Thank you, Mareike. And back to you, Mauricio, the key word that Mareike just mentioned, socio-technical. And Martine's question to you, Mauricio, was, how do you think the scale of socio-technical systems modify the methodologies of design?
Thank you, Katina. No, this. So one of the things I have developed in my thinking is this idea, okay, how traditional designers do things. And there are a couple of things that are very central to design, which are this idea of design synthesis, which is very related to creativity, the ability to deal with uncertainty. So very traditional design skills. And the other one is modeling. So designers have the ability to make things concrete, like with prototypes, models. And this is important in traditional design, but when you go to these higher levels, I mean, not just social systems, but also organizations or services, other things become important, like this idea of speculation or anticipation, which Mareike was just discussing. So I think it's important for designers that are working in broader problems or more complex socio-technical systems to have better anticipation and speculation skills. Another one that I mentioned is participation and facilitation, how designers can facilitate processes and involve other stakeholders. And another one would be implementation, like how you can not just deliver something, but also work in implementation. Because in the design, these traditional design practices are, okay, I design this, deliver, and go to the next project. I think designers have to become part of implementation and ongoing projects, not just deliver and say bye, but deliver, observe, analyze, redesign, and commit in the longer term.
And Mauricio, is everyone a designer in society?
Good question, good question. I would say that design is a human ability. So everybody designs. Like, no, it's like the example I have, typical example I have is math. Everyone can do math, but there are mathematicians that have a professional expertise. It's the same for design. And then we have different design disciplines. If you are talking about architecture, of course, not everybody is an architect. You need some specific skills for that. But if you are designing visions for the future, I don't think everybody is able to do that. Not many people with a professional design degree is a good designer of future visions of socio-technical systems. Some of them are, but what I argue is that if you are a designer and want to work in that space, you have to get some political skills, economy, or become an economist or management, and so many other disciplines. You have to become an hybrid practitioner to be able to work in that space.
Thanks, Mauricio. We have the absolute legend online as well, Eric Fisher. I'm not sure, Eric, if you can unmute at all or come on with us.
Hey, Kat. Hello, everybody.
Hello. We've been talking about you. I don't know if you've noticed.
Well, Mareike knows my comments on her project, and I think it's nice to see this iteration of it. But I would like to understand a little bit more how the reflexive practitioner dialogues would be structured and would relate to the idea of not just engaging practitioners, but also engaging visions.
Yeah, so this is a very important practical question that we are grappling with. And I think one of the solutions, possibly, where I'm still not really sure how to combine that with actual data collection for our social science research, but which I think could potentially be fruitful, are the reflexive practitioner dialogues that Eric and me have been developing in my PhD research, and that potentially be helpful also as self-reflective tools that you give to different people involved in the innovation ecosystem. And I think why I also bring them up here again is because we've just talked about how everyone is a designer, but there are people with more and people with less expertise. And I think we can also say that socio-technical integration is happening everywhere all the time, and people have capacities for doing so, but at different levels of expertise. So in a way, I think using a tool that can help us build these reflexive capacities can be helpful. And just structuring reflection already helps, making room for reflection. And I think our task would be to become these kinds of engagement agents, as I just introduced the concept here, instead of embedded humanists. So basically not people who are involved with one specific laboratory group for a long time. That's simply impossible if we want to engage an entire ecosystem, but really basically setting reflexive practitioner dialogues, bringing them into specific organizations, teaching them there to basically set an impulse that hopefully has ripple off effects. And that, of course, needs for us, requires for us that we identify the right people who become further change agents or engagement agents in their own institutions. So we need to find people who are really interested in our method and interested to take up the socio-ethical reflexive component, and then do it further with their colleagues. And again, this is probably, yeah, will require some work to identify those people, but that I think that's also why we do a stakeholder analysis in the first place and talk with different peoples to get a better picture of who to approach where and when, so that we basically organize these socio-technical integration workshops for the right people at the right time, so to say, and that it then kind of ripples through the entire innovation ecosystem. That's at least the idea where I think we could go. And then you asked also about the relation between anticipation and reflexivity, or let's say the STEER method more specifically. And there I would say, of course, you can organize scenario workshops which specifically target anticipation and really makes people think about different ways in which the innovation ecosystem and the technology itself could be, how this could further evolve. But I think another way to stimulate anticipation is also through the socio-technical integration research method, because there it's all about decision making and thinking about how you could make decisions differently. And this also involves some anticipation, because it requires you to think about what I'm doing now, to what extent will it have effects in the future. And so I think through the method, we can actually already address many of the components of or dimensions of the responsible innovation framework. So yeah, these are still some ideas, and further practical proposals need to be developed before we start working in August.
Yeah, no, these are really excellent ideas, Mareike. I have two suggestions. One is that in addition to doing the reflexive practitioner dialogues in a workshop format, that you build a facility so that they can go on more discreetly and informally among groups of 2 and 4. I think this is very important, rather than tying it to the workshop. the workshop is really just the training, the introduction. And the other idea is that if you can then link these dispersed reflexive practitioner dialogues to the scenarios and the scenario building, this would then ground the scenarios within practices, and it would also provide a sort of ballast for the practitioner dialogues that they can relate to this. But of course, yeah, these are just many ideas of, you have many more that are even better. So I love both presentations today. It was really a wonderful colloquium.
Thank you, friends. We've got time for just one more question, and that one I'll target to Mauricio just in the consciousness of time. And we've got Pooja Chitra with us. Over to you, Pooja.
Hi, wonderful presentations. I enjoyed both of them. And hello, Professor. Nice to meet you again. And I'm Mareike. Hi, it was nice to listen to you. Again, like Dr. Michael said, that there were a lot of parallels between both. So I have got one question, and this is more about translating what we do at STS to, going to practical design conversations. So this is when we are talking to policy designers or non-designer people and non-experts. Where do we start having these conversations about, how technology or the other artifacts like laws, contribute to how design is made, as in when both the design for change method and the STIR method focuses on understanding the perception of actors, but how do we understand what the contribution of technology is? Like, for example, if we are trying to design a behavioral nudge, to do that we have data that is collected probably through quantified systems or IT systems. So when do we start talking about those when we are having these design workshops? Like, where exactly do we put this?
That's, I mean, I'm not sure if I understand the question fully, but one of the things that I argue is that sometimes we are a metric-driven community in general. I mean, in experts in general kind of say, okay, we have to come up with an intervention and how we measure it. So I have a critique of behavioral economics in design. And what I say is that when you use behavioral theory to make decisions about designing for behavior or for behavior change, you end up creating something that can be measured. So, I mean, the example would be obesity. I mean, if you are trying to design for obesity, to prevent obesity, so maybe an easy solution would be, okay, let's come up with this intervention in which you design something so people eat more vegetables or people drink less soda. So you end up coming up with a very specific behavior. But then the complex challenge that we have are not about particular variables, are things that are very hard to measure. And then evidence becomes very tricky. So one of the things I have been thinking lately, there is a method in design called critique. So when you have a scientific-driven intervention, usually you have to have a metric in order to say, okay, this could be something that works. But in design, when you design something, let's say, I mean, even a traditional design artifact like a building, what do you measure to say that this building was successful? There is no single metric to do that. You can measure if the building is energy efficient, and then you might design for energy efficiency, but you have to design the whole building. You have to design energy efficiency, you have to design good satisfaction of occupants, you have to design for good lighting, you have to design for traffic flow. So how do you measure something that has so many variables? So the design method that we have is called critique, which is basically having a group of stakeholders. It could be experts or it could be different participants who are assessing these ideas. So I would say, I mean, actually, I have to say, I think if you are going to design for complex problems, evidence-based design is not the best option. It's imagination.
I think with that, we'll move to Dr. Abbas to close, if possible.
We are unfortunately out of time for today's session. My co-host Katina, Michael, and I would like to thank our speakers, Associate Professor Mauricio Mejía and Mareike Smolka, for joining us today and contributing to the discussion on designing for health, sustainability, and human values at the Public Interest Technology Colloquium. Thank you yet again to Melissa Waite and Anna Reed from ASU and to our live attendees. Before we close, a reminder that the recording for this session will be available on the School for the Future of Innovation in Society's YouTube channel. We wish you all a lovely day and look forward to seeing you for the final session in Series 3 of the Public Interest Technology Colloquium next week. Thank you.